And then, I definitely would recommend using the injection to fuzz or your applications as part of your automated tests. So that, if you've found that, oh, sometime we once had a buffer overflow in this thing, or we once had some integer overflow issues, those get reintroduced all the time by accident. And if you keep, there's no reason not to reuse a tool like this every night. Just keep it running. So that kind of wraps up named pipes. I'm going to just talk about shared sections briefly. Shared sections are a different IPC mechanism. They're not as common, but you will probably be surprised if you run that handles.exe program pipe grep negative I section. You might pipe WC negative L. You might be surprised how many lines of output come out of it. You have quite a few shared sections on your machine. And these things are even more dangerous to share because, as I mentioned before, they're often named, so they're discoverable, so they can be used by other users. And they don't have an integrated synchronization scheme. So data validation techniques, like say I wanted to do a strlen on some string that was in the section to make sure it was no bigger than the buffer I want to copy it into, and then I do a stir copy, well, that's a serious bug because there's a race condition between the time I do the strlen and the time that I do the stir copy. So that can be really problematic. A lot of functions aren't thread safe. And you don't want to mess around and hope that the implementation works the way that you think it works. And then when the next service pack comes out, find out that, oh, it doesn't actually guarantee that it works that way just because it happened to be. Or it works just fine on a uniprocessor machine, but on a dual core it has problems. Or, yeah, anyway. So if you don't have a guarantee of its thread safety characteristics, don't trust it. Usually shared sections are associated with some additional signaling message or mechanism, like an event or a named pipe. And we can discover them using the same techniques that we used for finding the named pipes, including the sysinternals tools. I've kind of covered this already, but the synchronization, usually these things are just convention-based, these synchronization schemes. So be on the lookout for synchronization-based conventions that are supposed to be secure. So two techniques for fuzzing these things. One's called scribbling. That's just pushing bad data in. And the other one's called asynchronous scribbling. And what this tries to do is, in addition to doing random fault injection, it also breaks the convention around when threads are going to be updating this. So we can take advantage of race conditions in the validation code and find those. So, how to scribble? Well, first thing you do is you start a test server running. You should run a test client at least once to kind of get the structures. Like when someone writes a message to a named pipe, it usually is just left sitting in the section. Sorry, when someone writes a message to a server through a shared section, the message is usually just left sitting in the shared section when it's done. So if you run the client a couple times, you can kind of prime it. Then you map the shared section into your fuzzer's address space, make a couple of changes, and start signaling the server, hey, try now, try now, try now. And you've got your WinDebug running. Maybe you've set it as your post-mortem debugger by saying WinDebug negative I. You should be able to find non-synchronization-based issues with the parsing routines. Oh, problem with that is that you need to know what the synchronization scheme is. You can guess if the server's got one event and one shared section that they're probably related, but you don't necessarily know. And it could be something totally unrelated. It could be that the user clicks a mouse, or it could be anything. So, not my favorite way to go. My favorite way to go is with the asynchronous scribbling. This one's more automatable because you don't need to actually understand how the server and client are talking to each other. You don't need to know the signaling mechanism. All you need to know is that they're using some shared section. So you take that shared section and you start writing into it. And you start a server and a client doing an automated regression. They're running through, doing a full functionality test, and you're just writing randomly into that shared section. And if there's any problems with their data validation or race conditions, the odds are you're going to hit them. That's the kind of, let's see. Yeah, that's the kind of fuzzer we have here. It's included in the tools that we're distributing. Oh yeah, we also included a C-types foreign function interface front end for this, for a bunch of Win32, or for a bunch of section-related Win32 things. This little fuzzer does is it takes the name of a shared section. I've got the target section is the name of this section, but you can try any section you want. And you can do things like random faults, -r, just puts random junk in there, null the whole thing out, max the whole thing out, so set everything in the section to 1 or 0, which can cause strange errors sometimes. If you see, you know, if at any point a pointer is being read or read out of that thing, just by maxing it out, you can see that immediately. And that's sort of like kind of the very first layer of problem that you tend to see coming out of these things, like people have just marshaled structs back and forth in them, and oh, we get a pointer out of there. And, so if that's happening, this will immediately find it. Same with offsets. If people are marshaling, oh, here's an array and it's got an offset in there, well, you set it all to FFFF, and that'll cause protection faults. And we can catch those in the debugger and then figure out what's going on. The -L option just tells it to loop, so it runs this over and over again. And it's kind of boring to watch if it's not actually finding bugs, so I just put in a static screenshot. So, defending against this, well, unfortunately, the big advantage of the shared section is that it's super, super fast. This doesn't take away from the speed that much, but I know you don't want to do it, but you have to copy the content of the shared section into some non-shared memory before you do anything with it. The very first thing your server should do when it receives that signal is not do data validation and make sure that the information's all, you know, inside the spec that you expect. No, just take it and copy it. Then, once you've got it copied, you can look into it and see, hey, is there something in here that shouldn't be in here? Is this string too long? Whatever kind of data validation you do, both the semantic and the syntactic validation that you want to do prior to passing it along to the application to generate a response. The other thing you should definitely do is consider locking down the ACLs on those. Often that's a design change and not the kind of thing that you can just patch into software, whereas this copying solution is. But it's certainly a better general purpose thing because it'll find the bug that you missed. So I'd like to just thank Scott Stender of ISEC for helping with this, and he's helped me a lot with my various Win32 IPC fuzzing stuff. Obviously, at ISEC, we've got teams of people that work together, and you know, this stuff is based on the work that we've done for a bunch of different clients, and just generally, if you need help with this kind of stuff, feel free to give us a call. Any questions? Oh, yeah, go ahead. The way that so I'm using Matt Conover's the x86 hook library, and the way that it works is it overwrites the instructions, the first couple of instructions of the preamble with a jump into his library, and then his library actually allows a pre and post hook, as well as it gives you a trampoline back to the kernel 32 call. Actually, if you use his library, the hook function that I implement is the pre-hook, and it automatically passes the results through to the actual function call itself. So I can change the parameters if I want, but I don't have to. And in fact, I do have to change the parameters for the hooking one, but not for the spying one. Any other questions? Okay, well, thanks for, oh, yeah. Himanshu Dwivedi has them, and he's right down here. Maybe if he comes forward. But there are also, the tools are available with an updated version of the slides from www.isecpartners.com. Any more? All right, thanks.